Welcome to episode 7 of our 3ds Max animation course. My name is Arnold Faller and today we're going to deal with particle systems. So I'm going to give you an overview of how to get started with particle system, what the major elements of a particle flow are, how we can edit them, and so on. So let's get started. I'm starting with a brand new Max file here, and I'm going to start by adding the first element of the particle system, and that is here under create, and you're going to switch from standard primitive to particle systems, and what we're going to add is a PF source, particle flow source. So you click on particle flow source. Right now the particle flow source is a rectangle of a certain size, but you just go into your top view and you drag a rectangle of any size into the scene. That's it for right now. So if you look from the, let me turn off the background grid with the letter G, turns off the background grid. So if you look in your front view and you move your time slider, you can see now that suddenly particles are falling down. They are not falling down actually, they are just moving in a downward direction. You can tell that when you select your, and I'm going to stay in my front view here and maximize it for you guys. If you take it in the front view, select it, use the move tool and rotate it, for example, to point upward, and then you move your time slider, you can see that those particles now will move upwards. You can see there's an arrow, and that is the direction that the particles are coming out. Those little ticks here, those little plus symbols, they stand for, of course, particles. Not all of those particles more than the particles that you see right now will be shown once you render it. And when you move your time slider to like 10 or 15 frames, that means the first particles are coming out. When you now hit render, you can see that my particles right now have a default shape of a little box or a cube, and you can see that there are much more than actually are represented with a little tick here. Also, when you move your time slider forward a little bit, you can notice that at frame 30 the particles stop coming out of the particle emitter and they just continue to fly in the direction they came out. So this is called the birth. So there's a birth event between 0 and 30, and during that time the particles are born and then they just live on. So they're not born anymore, but they're living on. They all have, you can see they all have the same speed, so they move in a block, like they're not changing, they don't have individual speed differences, and they just keep on moving. So there's no gravity, there's not any force, there's nothing stopping them, they will fly forever. Let's have a look at the particle view, and this is the most important keyboard shortcut you need when it comes to particles, and that is the letter 6 on your keyboard. So when you press 6, it will open the particle view window. Yours might look like this when you open it for the first time. So it might look like this. The particle view window is, I'm going to make it a little bit larger, is you can zoom in, zoom out. So right now it should only contain one particle source. This is the one that we've created. Down here, and you can increase the size of those elements. You have all kinds of elements that can be dragged into the scene. I personally usually start a particle system by creating, as we did here, the PF source. When you create the PF source in the particle view, it automatically creates a standard particle flow. That's what here. You could also create a particle system by picking for example, a standard flow and pull it out. I'm not going to do this right now. I'm going to show you later on what it does. For right now, we're just using other elements here. And you can see that the elements have different symbols here, the green ones, the blue ones, then the yellow symbols, and then there's some additional ones, gray rectangles. And those are usually placed on my particle flow here, and you can see the flow is actually made out of two parts. The first one, you could say, is responsible for showing the particles, rendering the particles in your scene, And the second, the event here, is responsible for creating for that something is happening. Let's go quickly through those. Let's see the first one here. What it renders is, first one, render. It renders whatever geometry is defined below. So it doesn't do anything else. It's just rendering the geometry is defined. Let me move that away. The geometry is defined somewhere else. You could also say, let's render none. Then obviously when you now hit render, it's not rendering anything for speed purposes and so on, or just the bounding boxes. But let's keep this to geometry. Let's go down into the event, and the event, let's start reading it from top to bottom. So usually every frame, this is quickly going through for every particle, and it starts here with the birth of the particles. And you can see the birth starts at 0 and it ends at 30. So during that time, that is 31 frames, a total amount of 200 particles are born. So you can define the amount of particles by the total amount, or you can also define a certain rate, like how many particles. So if I choose, for example, 30 particles per second, that means every 25, right now I think 30 is the frame rate defined. In 30 frames, you will have 60 particles, so much less than the total amount of 200. It's actually just, let's keep the amount of 200. Then the next one, where are the particles born? The particles are born on the volume of the emitter. So that's the emitter, the rectangle. If I'm going to zoom into a perspective, you can see that is a rectangle, and they are randomly born anywhere on the rectangle. So it's all over the volume of the rectangle. You can say, for example, you want it, some emitters look different, so there's a difference between surface and volume. Some are born vertices is also the same, so pivot would be different. Then the particles are all born in the center. Or edges, then obviously they are just born around the edges. They are also born here, I guess, in a diagonal edge. But let's keep this to volume or surface. Doesn't matter. Good. One thing that might be important later on, maybe you could also create lock on emitter. It doesn't make much sense now, but the particles are born, and instead of flying away, they just stick to the emitter. So when you render it now, you have the emitter, and all the particles just stick to it. That is necessary when you later on do something else with the particles, like get some wind and make them blow away, or have some dust collision, things like this. So sometimes it's quite helpful when you can keep them on the emitter, but usually this is not turned on. Inherit emitter movement. Of course, the emitter can also move. For example, if you have the emitter on the back of a rocket, so in the rocket where the engine is exhausting fumes and fire and so on, then you can link it to the rocket, and then the emitter gives the particles a certain speed, so they get speed from the emitter. Let's talk about speed. So here is speed. Right now my speed is defined in 300. What's that? 300 is 300 units, in my case meters, 300 units per second. So basically faster, slower. What you can just increase it or lower it. The variation is a speed variation, and right now I have 0 speed variation. So if I type in 100 speed variation and then move my particles, then you can see, okay, maybe you can't see, let's do 200. Then you have a speed variation of 200. Now you can see some particles are much slower, much faster. Some are much faster. So that is the variation of speed. Usually the direction of speed, they move along the icon arrow. So they come out and move in this direction. There is also some random 3D movement. If you just want them to fly in any direction, then they will come up with random 3D and so on. So a lot of things for you guys to try out. Reverse, then of course it's going the opposite direction. Divergence, like See, then they have some kind of random deviation to it. So let's take that to 0. The uniqueness, it basically means when you create two particle systems with the same seed factor for uniqueness, they will create the same particle systems. If you want to be randomly different, you should make sure that they have a different random seed. So there's no real random in computer programs. They all get generated from something that's called a seed. So make sure if you want to make them different, just make sure they have different random seeds. Next thing is rotation. Basically, mine are that means the rotation of every single object. It will not continue to rotate, but it will get an initial rotation, and this is what we see. So when we render it, you can see that the boxes all have some kind of random rotation, but they're not rotating anymore. That would go someplace else. So if you say, for example, they just have a horizontal random, then they are all parallel, but they have only a rotation around the z-axis local, and so on and so on. Here, let's keep this to random 3D. Also, here is a randomness in it. What is the shape of my cube? And that is the first thing that we can do a lot of changes. What do we see? We see cubes right now, and there's different shapes. There's a couple of different shapes. There's 2D shapes and 3D shapes. Those are ready built-in possible shapes that you can choose. You can also define the size of it right now. So here's the size. You can also scale it. You can also have a scale variation. Let's do a scale variation of 100%. So now the cubes should all be different size. No, they are scaling. Basically means that they are growing. They are scaled 100%, I think, each second. So every second they will get 100% bigger. So the big ones, the small ones, and a variation of 100%. So it will also get scaled up and down. Let's turn this off. I don't want it. And the last thing is display. This is what we see on screen. So display here is defining what I see on screen. Right now I just see those little ticks and those little ticks, and also shape. Let me quickly speed. Yeah, that's okay. So the ticks, and if I change it to geometry, for example, I can see the actual geometry. So if I go into a shaded view, I see my actual particles and what shape they will have at the end. And also when you render it, you even get more. I don't know why, but sometimes here I was just looking for it. Somewhere it must have more geometry than actually particles. So here's 100% visible. Let's go quickly through all the. There's also 100% visible. There's also position. It's positioning, speed. There's no. That is strange. It's not showing less than it. Okay. So it's not exactly the same particles that you see here. There's more when you render it. Okay. Let's get to something a little bit more sophisticated. Let's add something to my particle system. So right now my particles, they spray. Let's remember from the front. If I look from the front, then they all move up. So let's turn it into a 45-degree angle, or yeah, doesn't matter, maybe 30 degrees. So a little bit steeper than 45 degrees. Also my birth event I'm going to change so that the particles are emitted from 0 to 50 or 60 maybe, so that it looks like less particles, but now they are longer born. So they are born during the first 60 frames. And now I'm going to add a force, and the force will be gravity. So to add a force, you need two things. You have to first define where is the force. That is done with the force object. And the second thing is you somehow have to include it into your particle event. Let's get the force first. Here under create, under create, you will find the helpers for, oh, sorry, that's wrong. Create. Here it is. Create space warps and forces. And here's the simple one, gravity. So create, and here's the space warps, the little waves, and then switch, oh, it's already switched to forces, and here's gravity. Let's add gravity to our scene. Gravity, if I add it in a perspective view or top view, will usually point down. It doesn't matter how big the symbol is that I add. The strength is usually 1. So it just means if you want to make it stronger or weaker, this is where you can change that. So the icon size does not mean that there is stronger gravity or more gravity. It's also everywhere. It's not only limited to the place of the icon. So you can place the icon wherever you want. So let's put it on the other side. Let's go back to the front view and let's add it to our particle system. Therefore, you hit 6 on your keyboard, opens up the particle flow, and now the gravity has to go somewhere into our event. And the gravity in this case is a force, and that is a blue symbol here. And when you click on the new operator, force, you can see force accepts any force type particle space warp as a force source. So there's wind and spray and all kinds of things. The force is applied to all particles in the current event. So all the particles that are born here will have this force. Let's take it, pull it into the force. You can place it anywhere actually. Let's put it all the way to the bottom. I usually put it before the display, but it's the same thing. So now if you click on this force here, you can add different forces in your system, and I would like to add, of course, my gravity. So here's the list, and I'm going to add, click on the gravity, or you can also say add by list, and then it opens up a window and you can pick the force that you want to add. So here it is, and now the influence is 1000%. Again, doesn't say a lot about the strength of it, but we don't have to find any weight and so on. But this is something that is usually very strong. So when the particles are now coming out of the emitter with a certain initial speed of 300 units per second, the gravity kicks in right away, and then they will are pulled down. To make it more visible, I'm going to lower the intensity of the gravity. Let's go for still 500 a lot. Let's go for 100. Yeah. So let's try 250. Yes. So with 250, you can see that they still fly out. They are fast enough to fight the gravity, but at a certain point, gravity is stronger because they don't get any. The speed is just an initial speed, and it will slow down, and then it reaches, of course, 0, and then it will fall down, and it will get a curve like this. So the force can be placed anywhere. Just make sure you don't place it on something else, because then it will be overwritten. So just to show you, let me get anything in here, shape facing, and now when I take something else, let's say placement paint, and I put it on top of it, it removes it. But you can also select the one you placed and hit delete, and it's gone. Oh, what did I just reset something. Really? Oh. I have overwritten something else. So place, why do I have, so I placed it on something else. So this is the one I tried, and to put something else on top, you override it like this, but you can also delete it. So now we are back. Let's get my force all the way down so I know what I have added to the system. So there it is. Okay, so that is a regular operator inside my event. There is not only those regular operators for force, but there's also some other ones, the yellow ones, that I'm going to use right now. So the next thing is, let's try something else, a different kind of force, and that is a deflector. As a deflector, and I'm going to close it here. Here under Create, you will also find deflectors. So under the space warps where we have forces right now, here's also deflectors. And let's pick the deflector without anything, U deflector, Omni deflect, and so on. Just a regular deflector that is a plane. And I'm going into top view, and I'm going to create a large enough plane to place it just like a ground plane here where my particles would fall down. In front view, I'm going to place the deflector somewhere here. So the particles will be flying up, hit by gravity, fall down, and then they suddenly hit the deflector. The deflector is just like a plane, and I will make it bounce off. To add the deflector to the scene, I hit 6 on my keyboard to open the flow. To add the deflector here, what we need to do is we need to do a so-called test. So this time it's not one of the blue one, it is a yellow one, and we're going to try the collision test. That's the second one, collision here. And when you look at it, collision accept any deflector type particle space warps, that's the plane, for a collision test. And the collision test basically means the particles are tested, and let's look from the front quickly, and you can see all those particles. It's tested. Have you passed the deflector, yes or no? And have you passed? No. Have you passed? No. And as soon as it passes, the test returns true. So it's false, 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 and as soon as one passes it, it's true. Because the deflector not necessarily needs to make them bounce off. It can also test them and do something else with it. Let's do that first. So let's take the deflector collision test, the collision, and bring it in. I'm going to put it right below force. You can see right away that the collision is a different operator in the event because it has a node going out. So you can test it, and if the collision is true, like it has been collided, you can move it into a different event, one that does something else, and so on. So let's hit collision, and by collision, you can add your deflector. So the collision itself does nothing. You have to add the deflector. This time I'm going to add it by list. So I'm going to hit by list. Sorry, it always opens in another screen. So here it is, deflector, and now the deflector is added to the list. And now you can see it bounces off because it says it tests through if the particle collide. What is it doing? It bounces off. So right now it's set to bounce, but you can also say continue. Then it's not going to bounce off, but it's just testing through, and it's going into a new event. But let's keep it to bounce so we see what it does. So every particle here is tested, and as soon as it turns true, it bounces off. It means the speed, the direction is the incoming angle is the same as the outgoing angle. It bounces off like a wave here. Again, it bounces off till the gravity is strong, and then it falls down again, and it does the same thing twice if the animation is long enough. As I said, particles are living forever, so they will bounce forever. Or, of course, if the deflector is not big enough, then it will fall down after the deflector. Okay, so that's it. So it bounces off. When it says, there's also a lot of other things here, which we can talk about later. So right now what's interesting, what you can do is, if you don't use the outgoing node here to transfer all the particles into a new event, they will continue to stay in this event, it means they will have the same forces and so on and so on. So they will continue, they will bounce again because they are still in the same event. Let's create a new event. And a new event doesn't mean you don't need a new source, you just need the new event. And you know what I'm doing? I'm gonna select this event here and I'm gonna copy and paste it. So what I did is I just selected it and I use Shift and move it and create a copy of everything. So here's the copy of the event. It just has a new number, birth event. So my copy of the event has a few things they don't need. It doesn't need the birth because in my event they come from the other event and they are already born there. So remove the birth. Also the position, because the position is where are they born on the emitter. So let's select this one and define it as well. The speed, it defined what's the initial speed. They already have a speed when they're coming, so we don't need the speed. We also don't need the shape, we need the shape, but we don't need the rotation because they're already coming with a rotation. And from bouncing off, the rotation changes and so on. So let's delete that as well. We need a shape because we want a certain shape. We need a display because we want to see them. Let's try to make display in a different color. So I'm going to switch the green here to a red. So from now on they should be red. The gravity, let's say the gravity is also in the new event and they will still collide to the deflector. So when they bounce again, they will do that. So now let's just bring the event here and link the collision here to the new event. So that means as soon as a particle is tested positive for collision, it will continue in the new event. It will no longer be in this one. And we can best see that their color switches from green to red. Okay, so the red ones are in the new particle. If you want, for example, there is no gravity here, so you can just click on the icon and turn the gravity off. You can see as soon as they bounce, they will continue to fly forever because they are in no gravity. Gravity stronger, something else like this. If the display, no, let's do the shape. If the shape right now is a cube, we can also say after the, in the new event, it's a sphere. Then they will change their form. And so on. So let's keep that as it is. Is the concept clear of moving it from one event to the other with a collision test? The second test will not do anything because again we could test it for the second time and then we can bring it into, oh, you know what we're going to do? We do that. Let's test it one more time. Right now my particles are flying at 100, see at 100 frame we're almost at the end. Let's make my animation a little bit longer. So I'm going to hit the time configuration button and I'm going to make an end time of 150. So my whole timeline is now a little bit longer. The particles fly forever, so they will bounce a second time and maybe even a third time. No, at the end the deflector is too small. So let's test it one more time. Here in the second, when they are red, again, they are tested for colliding with the same deflector. And again, they will bounce, but I'm going to move them into a new event, and this event will be a really short one because I am just killing them. So instead of making a copy of the whole event, what I do is here's an event that's called delete. Meaning, if I take the delete event and pull it out into the empty, it will automatically create the smallest possible event, and that is a delete with display. Makes not much sense because when you delete it, you don't want it to be displayed, but that's anything else, if you pull it out, will always come with a display. So this is the only thing you need. The particles need to be seen, displayed. And then, of course, they are rendered here in this event of the flow. So this is the smallest possible thing. And now I'm going to link my second collision test. And when it's positive, they go into the new event where they are right away deleted. You can see I am deleting or only selected or only particles after a certain age and so on. So we now have a much more complex event, series of events. So we're always here. As soon as we deflect for the first time, we go into the red event, do the same thing again with all the necessary things like display and shape. And actually, see, we don't need the shape at all. If I take the shape and turn it off, they don't get a new shape, they just keep the old shape. So that is something we don't need in here unless we want to change it. The only important is they have to be displayed. There has to be a certain force, gravity, and the collision, the new collision, the second one, when they're red. And then you can see now they die on collision. As soon as the particle hits the deflector, they go into the new event and they die. Okay, so that is a very simple particle flow that has a couple of forces in them and a couple of tests where the one test is going into a new event and the other test is going into a delete event. Let's see another thing, and I'm going to create it one more time. So let's create quickly a new event. So I am just kicking out everything of the old one and create a new PF source of this kind. Again, to make sure it's not gravity that is making them falling down, I'm looking from the front. I am again rotating them up in 45 degrees or so that they point upwards. So the particles now come out in the way we already know. Let's open up the particle flow. Oh, by deleting it, by the way, it did not delete. It did not delete the old one. So this is the new one. My birth is born between 0 and 30. Let's turn that off. My timeline is 150 frames long, so I want them to be born all the time. So from 0 to 150. That means maybe the total amount could be more, but let's leave it as it is. Here it is. Maybe let's make it amount 300. So every frame, 2 particles are born. So, and they all fly out like this. Let's do something else, another test, and that is, let's do an age test. The age test is often used for doing something to particles that get a certain age. Let's put it in here, the age test, click on it, and let's, what you can do, you can test for different ages. You can test for the particle age. Okay, that's it. Then for the absolute age means maybe if the particle is born not at the beginning but a little bit later, it actually uses the whole time. And the last one, the event age, would be the age as long as it is in the event. So in this case, it's the same as the particle age. But if you move your particle with a test, for example, into a new event, the particle age is not changing, it's not reset, but the event age is starting from the beginning. So you can test for different ages. I'm going to check for particle age. And right now, they all are born for 150 frames. So I'm going to check my particle age older than 50. So let's see, I'm checking if my particle age is greater than a certain test value, and the test value is 50. with a variation, let's make it a bit more, 10. So as soon as they reach 50 frames of age, plus minus 10, so there's a little randomness in it, they are tested positive. So the test event of the test stage here is tested positive. And what I'm going to do with the event, let's just, once they turn into they turn a certain age, they will, I don't know what, let's say they turn into a different shape. So I'm going to use my shape, as shape. I'm going to use my shape into an empty event. So before that, they are displayed here. Let me go to display and display them as geometry. Before that, here they are. Blue and cubes. Where are the position, shape, cubes? Let's make the cubes a bit bigger. So here they are. And then they go into a new event where the new event is not a cube anymore, but they're going to turn it into a sphere with the same size, 20. So now the new event has all the same things. The display, the speed, the rotation all comes from before. What we change, we put into the new event. In this case, we change the shape. And I'm going to change the color. They go into a green color. Also display geometry. So we see on screen, I don't have to render it all the time. Geometry. And there it is, going from age to this. So now when I move my time slider, you can notice that at a certain point somewhere around the age of 50, so it's a plus minus 10, or I think I have set it. So from 40 to 60, all the particles somehow change their color and their shape. So this is how you can test them for a certain age. Of course, you can put anything new in the event. You can make a new shape, a new force, a new something like gravity, and so on. So we've already talked, or I have already talked about, what's the time? 37 minutes. So let's sum it up. To create a particle event, I would suggest to create a PF source first, and usually it comes with those two without this one, so it just comes with a particle source that is rendered and with a series of operators in an event. Then you can add all kinds of things into the event. If you want to bring it into a new event, you can always test it somehow, either with a deflector or with a collision, or in this case, or with a shape, with an age, for example, and so on. You can also move all of them if you want, copy out. So there's plenty of other things there for you guys to test. And then when you're in the new event, you only need the additional things and the very essential ones. That is the display of the new geometry. So if you want to explore a little bit more, there is also other events here. Let's quickly delete everything. I'm going to get rid of this event, and I'm also going to get rid of what I did so far here. There is also the standard flow that I have created there can also be started by taking a standard flow and pull it out. So here it is. The only problem is the icon here is not defined. So you have to, oh, there it is. It automatically creates an icon. It is much smaller, and it has a random direction. No, it goes backwards. Yeah, depend on in which view you are. In this view, it's creating it. So I personally like to create it, create the PF source, and then I can move it to the right direction, and then I have the same thing here. But you can also get it by pulling it out. So let's pull out something else. There's also other ones. There's also an empty flow, which is basically no event there. So that is just the starting event, the one that's necessary for showing it, and then you can put all kinds of other events. You can create your own. Remember, we had a birth event, we had a birth, then we had the icon, and so on. So we could also do all these things by hand and then link it together and hopefully get the same event. Also, empty flow. We talk about, maybe we have time for the M particles. That's much more complex, so we're going to stay to the single ones. Yeah, and there's one that is maybe interesting if you want to find out something, what is possible. And if you take a preset flow, and the preset flow, when you pull it in, gives you a window of all kinds of preset particle systems. And you can see they're all by air. So it has all to do with smoke and smoke and things in the air, wind and so on, dust. Then it has to do with earth, something that's crawling around and so on. Let's try maybe bees later. Then fire and smoke, and then there's some logo flying and reassembling and dissolving, and there's some water spray and liquids and so on. Let's go for a simple, they don't all work properly, but you can see how they are built. And let's try to end it up with the earth. I just saw bees before. I don't know what that is, bees. Okay, so that's an old format. So it not only brings in a new particle system in the preset that you can find, but it also maybe gets some geometry there. So there's a camera, a light, and so on. So when you want to see it, the best way is to just hit C for camera, and then your scene is here. So in this case, it not only has a particle system, but it also has a person that is afraid of bees, and then you could see how it looks like when they're flying around. I'm not sure. Okay, it's inside a room, and let's see the bees coming out there. Okay, they're hard to see. They're actually probably some simplified geometry, and they have a lot of motion blur, so we don't see anything. Something that maybe we want to hide, this piece, I don't know, unfreeze all, hide, selection. I don't know why there is a, yeah. So it's not the best thing, but you can see how they are built. So they are have a birth event where the bees are born. Funny thing is, you can start emitting bees at -15. That means when you start your animation, they're already 15 out. Or not 15 bees, but they're already 15 frames before they started to come out at a frame rate of 80 per second. So that's already a couple of bees there. The next thing is they're born, then they are coming out of the emitter. This time it's a different emitter, but it's the same thing. It's a volume, not a rectangle. Then the display, they are just little ticks. See, there's little ticks. And then there is the send out. Basically, it means all the particles are then sent out into a new event. And all the things like wind and display, what it is, geometry. In this case, it's a shape instance. Maybe we'll talk next time about shape instance here. Then they have a certain speed. And I think that what's important here, they have a find target event, where it means it's trying to find, where does it say where? Try and find target. I don't know how to define the target. It's not defined here. You should define where they are flying. Oh, I think they just called it. They just called it find target. It is actually a regular speed event, is it? Let's quickly try it. No. Okay, and then they are somehow having a deflector in it. I don't know where the deflector is. The ground plane that makes them bounce off. Okay, so there's something that you can find out. As I said, they are not always working perfect, those elements, but see, because where do they fly? The bees don't know where to fly. Usually they should have a target. Let's quickly fix that. Let's hit 6, and here is the find target, and you define your target. Maybe you can do it with a mesh option. You need, maybe I deleted an icon or so. Mesh option. I'm gonna add the person's head. So head. So now the bees should try to seek to get to his head. Okay, maybe the wind is too strong. Force wind. Let's turn the wind off. What's happening then? Yes, then they go towards his head. That looks funny. Let's go to a camera view. So here it is. So now it works finally. When the wind was too strong, and then it also makes sense that he tries to get rid of the bees. So yes, here we are. Now they are all around his head. The bees, by the way, have a little. See, they almost look like bees. They have a shape instance, so that somewhere must be a bee like this, and they just linked it to the little bee geometry. Okay, guys, that's it for the introduction to the particle systems. I hope you liked it. Please play with it. There's so many things you can try out, especially with those default scenes that you can just look how they are built, and you come up with ideas and build your own thing. Next time I'm gonna have a few more selected topics with particle systems that I want to show you. Thanks for your attention, and I'll see you in the next one.